All right, so section 2.4, algebraic reasoning. Basically what we're looking at in this section is solving equations. And we're using solving equations to start to get the idea of how to solve a proof. A proof is just like solving an equation. So we're basically given the equation and we're trying to prove what the answer is for the x. So like if we're given this equation at the very top, that's the given equation. That's always your first reason here on this side. It says justification. The very last one is that what x equals -1. And so that's what we're trying to prove. So if you're given this and it says prove this, well, to prove it we would do all of this stuff. We would do all of the stuff in between. Okay, so I'm going to give you a minute here to try to come up with the reasons on this side. So the steps are all done for you, but what's the reason for them? And you can find those reasons over on page 51 and page 52. So if you look at those, you'll see the properties of equality, like add, subtract, multiply, divide. And then on the page 52, you're going to see a couple other ones, distributive property, and then reflexive, symmetric, transitive. Those are in there. And so you're going to use some of those properties, but then when you do that property, you can say simplify. Simplify is a word that you can use on several of these as you are doing it. You're going to see in bold where the bold part is, that's where you want to say the property, and then the next one down, just say simplify when you actually do that subtraction or addition or division or something. Okay, so let's go over this. So we're going to get rid of the parentheses on this one here. So your given statement has parentheses in it. And so then we get rid of them. So that's the distributive property. We should be familiar with that one. So just distributive property on the first line. That's what you did. And then from there, you had to combine 6 and -5 to get this 1 here. So you could either say combine like terms, that would have been fine, or you could say simplify. And I just said simplify on that one. But combined like terms would have been acceptable. And then you could see the bold part. What's going on here on both sides is you're subtracting -2x or -2x. So if you're doing that to both sides, that's a property of equality. And you're subtracting something from both sides, so that's the subtraction property of equality. And once we do that, so now we're going to actually do that, so we're simplifying our equation. And that's, again, just the word simplify would go next. Just simplify. So you're actually doing the 5x minus 2x to get the 3x. So you're simplifying the equation. And then the next one, they're showing that you're going to subtract 4 from both sides. So again, that's the same property, subtraction property of equality when they do that. And when they actually do it here, so we have the 1 minus 4 becoming -3, they're simplifying again. So just the word simplify again would work. And then the next one you can see in bold, they are dividing by 3 on both sides. So that's a division property of equality. And so then when they actually do the division, like -3 divided by 3 equals -1, that's just again the word simplify. They're simplifying the equation. And now this very last one where they're switching it over the equal sign, that would be the symmetric property. The symmetric property of equality. Whenever you want to switch something just around, just turn it around, switching it over the equal sign is just the symmetric property. There's -1 equals x, x is equal to -1. You can do that anytime you want to. We could have done that anytime we wanted to all the time. We could have switched it anytime, but we're switching it down here. So when you switch it around the equal sign, so basically the left side equals the right side can equal the left side. And so that's what they're doing. Okay, so this is on page 50, number 4, but we're going to use these lines here to write our justification, our reason for each step we do. So here's the equation here from number 4. I just wrote it next to the top line. I wrote given equation for my reason for my first statement. The first statement is the equation, and so your first reason is always going to be given. That's what's going to happen whenever you do a proof. Your first statement or your first statement is always going to be the given. That's the reason you give for that first statement. So now when we do this, we have to distribute that 3. We know that to get rid of the parentheses. So we multiply 3 times x, 3 times 1. So it'll look like this, 3x plus 3. then minus 1 equals the negative 13, and the reason for that, the property for that, would be the distributive property. And the next thing we would do is we would need to combine 3 minus 1 here. So if we combine that, we could either call it combine like terms, or we could call it simplify. So when we actually do that, we're going to be becoming 3x plus 2, because 3 minus 1 is 2. And we can call it simplify if we want to, or you could say combine like term, that's okay as well. The next thing we'd probably want to do is move the 2 over there where the negative 13 is. So we're going to want to subtract 2 from both sides, and that's the subtraction property of equality when we do that one. Subtraction property of equality, EQ for equality. Now when we actually do it, and we actually subtract the 2, and we get 3x equals negative 15, well, that we just simplified our equation, so we can write simplify again for that one. The next thing we want to do is get rid of our 3. We're going to want to divide both sides by 3 to get rid of the 3. That way the 3's cancel there. And so that is called the division property of equality, when we divide both sides by 3. And then when we actually do the division, and we actually now would write down x is equal to negative 5, that's just, again, simplify. We simplified our equation. So basically what we're trying to do is we're given this equation, we're trying to prove that x equals negative 5, and this is the process of doing that. You prove it by showing the statements and then writing the reasons, the justification for each statement. That is what a proof does. When we do the geometry proofs in the next two sections, 2.5, 2.6, are getting into the geometry proofs. We're starting to learn how to do those then. We'll be basically doing the same kind of thing. Okay, so our core concepts now, 51 has the properties of equality core concepts. And these are the addition, subtraction, multiplication, division that we were already just looking at. But it also includes substitution property of equality. I want you to highlight that one. Highlight that one because that's a really important one. We don't use the addition, subtraction, multiplication, division properties that much in the geometry proofs. But we do use this substitution property a lot, all the time in the geometry proofs. We're always using that property, and we're always going to use that reason when we use that property. So like if we know that something equals something, like A equals B, and maybe B is in some other equation, we can always substitute A in for B. So we always will use this property a lot when we're looking at segments or angles or something else that we're trying to prove in geometry. Substitution properties, that's a big one. On page 52, you can turn over to there. We see the distributive property, but we won't really use the distributive property hardly ever in the geometry proofs. It's used all the time with algebra, but hardly ever with geometry. The ones that we do use often, and you want to highlight these ones, is the reflexive, symmetric, and transitive property. Those ones we do use in geometry quite a bit. You can see how they are even applied to segment lengths and angle measures here. So reflexive property is basically when the same thing equals itself. A equals A. So it's like a reflection of itself. You're looking at a mirror image. AB equals AB. It's equal to itself. You call it reflexive. Sometimes we do use that property. The symmetric, we already saw that on that exploration. That's when you basically are just switching it over the equal sign. So A equals B, so B equals A. And that's what we're seeing here, and you can apply it to the segments and the angle measures. And highlight the transitive property because that's one that is used probably most often out of these three, in fact. We use that one probably the most of the three. That's the one that's like the law of syllogism that we learned a couple lessons ago, and I was saying this is like the transitive property that we got to come really familiar with. The transitive property is like the friend's property. Any friend of yours is a friend of mine kind of property, where you got, okay, well, A equals B and B equals C, well then by association, A is going to equal C. And same thing is applied over here with the segments or even the angles. You can see, well, angle A is going to equal angle C here because of this transitive property. They both are equal to B, so they can equal each other. So by association, they can equal each other. And we use that all the time. You know, if you can show that, well, this equals this, and this thing from here also equals this thing from here, so that means that these other two things can equal each other. And we're always writing a new statement using this transitive property as a reason. So you're going to be using this one and seeing this one come up a lot in the proofs that we do down the road. Okay, so we're on page 53 with the extra practice. 1 through 3, you're going to solve the equation, just like you did in algebra, just like you did algebra 1, really. But this time, we need to justify each step. You need to write the reason for each step, and the very first one is going to be given. So right next to each problem here, just write the word given. Given next to this one, next to the negative 19, write given. Next to negative 6, write given. Next to this parenthesis here, write given. That's the given part of our equation there. What you're trying to do is you're trying to solve for x. That way you can prove what x equals. You're proving that x equals a certain number when you do that, and you're going to justify each step. Use your properties of equality, distributive property, any of those things you have to say. So every time you just write down your step here, and then write the reason for that step next to it. Okay, so I'll give you some time to work through 1 through 3, and then we'll go over those. All right, so let's go over 1 through 3. So start with the given, just next to 19 right here. I'm just writing given for this first statement. And I even included down here x equals 6. So this is like a proof. So they give you this. They're going to say this is the given part. Prove x equals 6. So here's how we would just somehow prove it. And you could have done it a different way than I'm doing it here, but still got it right. I chose to move 5x over to this side, get the x's on the left side. So I'm going to subtract 5x from both sides to do that. And so my reason is just the subtraction property of equality for that one. And I put sub. I probably shouldn't have put sub just because that may sound like substitution as well. So I probably should actually put subtract. So when you see sub, I mean subtract here. And when you actually do it, so now I'm actually going to subtract it, I'm going to get negative 2x minus 7 equals negative 19. And that means I just simplified from here to here. So I just simplified on that one. Now if you did this in your head, if you didn't write this down and you did it in your head, then you still want to put the substitution property of equality, but you don't need to write simplify, you know. So I'm going to do that on the next two. The next thing I would do is I want to bring the negative 7, bring it over here to negative 19. So I'm going to add 7 to both sides, and that would be the addition property of equality to do that. And again, I'm going to then do the addition here. So it now gives me an equation of negative 2x equals negative 12. And that's again just simplifying the equation. And then the last thing I need to do is get rid of this negative 2 by dividing by negative 2 on both sides. And that is the division property of equality. And that then proves, once I do that, that negative 12 divided by negative 2 equals 6. That would be proving that. And I could just say simplify for that last one if I wanted to. But that's what would prove it. And then for number 20, we have our given again. So this just write the word given next to the 6 over here. So this is the given statement. And x equals 4. So prove that x equals 4. To do that, we would have to show the steps and the reasons for that. So we start off by distributing negative 2 into this parenthesis, and that would just be the distributive property for the reason. And then we want to combine like terms here with the 20 and the 2. So when I combine that, that's going to give me 22 minus 6x equals the x minus 6 on the other side. And you could either say simplify or combine like terms. I put combine like terms this time just to show you can say that too if you're going to combine like terms on the same side there. Then the next thing I'm going to do, I'm going to bring my x terms together on the left side. So I'm going to move x over to where 6x is. So I'm going to subtract x from both sides. And that I'm going to do in my head. So I'm just going to write it down. 22 minus 7x now. When I subtract an x from 6x, it makes a negative 7x equal to negative 6. So that was the subtraction property of equality. Again, I put sub there. And then I want to get my variable term by itself on the left. So I'm going to move 22 now to the right side. I got to subtract 22 from both sides. and that would be the subtraction property of equality when I do that. So I have now negative 7x is equal to negative 28. Negative 6 and a negative 22 would give me the negative 28. And again, the reason for that would be substitution, or not substitution, subtraction property of equality. See, my sub is getting me messed up. I should have put subtract. And then the last step here would be from going from here to x equals 4, we would divide by negative 7, and that's the division property of equality for our answer part. So for the x equals 4 part, that's the division property of equality. On 3, the first thing we have to do on 3, we'll write given. Okay, that's always the very first thing you're going to say is given for what you're given. And the after the given is just going to now, when we start to work this out, we're going to use the distributive property first. And so we actually do that by distributing negative 5 into this parenthesis, getting negative 10u minus 50, and distribute 2 into this one on this side, so 2u equals negative 14. And I'm going to write down distributive property for the reason. Then I'm going to decide what I want to move where. And so I decided to get the u's on the left side. So I'm going to move 2u over here to where negative 10u is. I got to subtract 2u. So that's going to give me negative 12u minus the 50 equals the negative 14 now. And that was subtraction property of equality. And again, I put the sub. And now I want to get 50, move that 50 over here. So I got to add 50 to both sides. So when I add 50, I'm going to get negative 12u is equal to positive 36. So I'm moving 50 this way. So basically 50 minus 14 would give me the 36. That's the addition property of equality when I added 50 to both sides. Then to get to my answer here, where u is equal to negative 3, that's how I'm trying to prove that, I would be dividing by the negative 12, which is the division property of equality there at the end. Okay, so if you look at the next two problems, 5 and 6, we're now going to be doing it with what we call literal equations, where you're going to solve for a variable. It's basically the same type of thing, solve the equation, but solve for y on number 4, and 5 solve for s. So go ahead and try right now, for number 4, solve the equation for y. It's just like a linear equation there. Solve it for y. Get it into like y equals mx plus b form on that one. And then, again, justify your steps. Okay, so let's see number 4 and 5 here. We're actually not going to do 6. We're just going to end this with 4 and 5. So we have to solve for y. And so the first thing we're going to do is write the word given as a reason. So here's our given equation, and the given thing they're telling us here is to solve it for y. So the first thing is just to write a reason for this, and that's given. And then we're going to start by solving for y by moving our 9x to the other side. So I got to subtract 9x from both sides, and that's just the subtraction property of equality when I do that. And then when I actually do the subtraction, it'll now say 2y is equal to negative 9x plus 5. And I'm just going to call that simplify, just simplified the equation. And then I'm going to just get my y by itself by dividing by 2. I got to divide this by 2 to get rid of the 2. So we're going to divide by 2, not just here, but on everything. And so again, that's a property of equality. We're equally dividing it. So we're going to call that one a division property of equality. And then when I actually do the division, we're going to now see the answer for y equals negative 9 over 2x plus 5 over 2. I'm going to just say that's simplified, just simplified this down to this. And for number 5, again, the first thing we write is given. Because we're going to write that for our given statement here, the given equation. We're going to solve it for s. So the first thing I'm going to do is get this term here, the 1/15th s by itself. I'm going to move this t term to the other side. So I'm going to add the 2/3 t to both sides. So that's just the addition property of equality when I'm doing that. And so then when I'm actually going to do that, when I actually do add them, I'm going to get 1/15th s is equal to 2/3 t minus 2. And I can just say I'm going to call it simplify. Simplified from here down to this equation. Now to get rid of my 1/15th in front of s, I need to multiply by 15. So I'm going to do that to both sides. I'm going to multiply both sides equally by 15. And so when I do that, the 15s will cross cancel here, leaving me just with x. And then 15, I'm going to distribute that into this parenthesis. When I distribute it here, 3 will cross out with 15, leaving me with 5. So there's still 5 left to multiply 2 with. That's going to be 10 for 10t. And then negative 2 times 15 is negative 30. So we're going to see an answer of s is equal to 10t minus 30. And again, what we did there was the multiplication property of equality. And so that concludes our lesson here on 2.4. And so we'll be ready to go on to our proofs. Our geometry proofs now is going to be in 2.5 and 2.6. So this is what this was gearing us up for, is getting ready for our statements and our reasons for the geometry proofs. All right, I'll see you then.